Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 1 and our main topic is on application of differentiation in finding the equations of tangent line and normal line. So first of all, we need to understand what we mean by tangent line and a normal line. I want us to consider the graph of the function. Consider the graph of the function y is equals to f of x. Let me draw it here. We will have the x-axis and the y-axis. This should be vertical line and a horizontal line, x, y. So let's say we have this kind of a graph like this one. That is y is equals to f of x. So at this point, let's call it point P. You can talk of let P x naught y naught be a point on the curve. So at that point, I want to draw a line that touches our curve at that point only. So we'll have this kind of a line, a straight line. They meet at point P. Let's call this point P. I can denote that by P. They meet at point P. I also want another line that is perpendicular to this line and touches the curve at the same point. This is another line. You see, those two lines are perpendicular. They meet at 90 degrees. So the first line, the one we drew in red, is called tangent. That is a tangent line. And the other one that is perpendicular to the tangent at point P is called a normal line. So then what do you understand by a tangent line? So we can define it that when we talk of tangent line, a tangent line touches, it touches the curve at only one point. A line which touches the curve at only one point is called the tangent line. So the point in this case is at point P. And only one point, that is P. What about a normal line? Normal line. It is a line that is perpendicular. It is perpendicular. It is perpendicular. This means perpendicular to the tangent line at P. It also passes through point P and perpendicular to our tangent line. Now, how do we apply the concept of differentiation to be able to find the equations of tangent line and normal line? So, if you want to know the slope of your curve at any point P of xy, this is what you do. You take note that dy let me write a note, NB to mean a note, that dy dx, this one gives the slope, it gives the gradient, slope stroke gradient of the curve y is equals to f of x at at any point xy on the curve. So dy dx, that is the interpretation. Dy dx is the rate of change, or simply the gradient of that curve at point x, y. What if now we know the point? Because you see xy is just a general point. If you know the particular point to be x naught, y naught, then what will that gradient mean? So you will now write, let m1, which is equals to dy dx, at the point x naught, y naught, that is point P. Point P was x naught, y naught. So now when you substitute the value of that coordinate, you get a specific value for your gradient. And this one will be the slope or gradient of tangent line at point P. So that's how you find the slope of the tangent line at that particular point P. But what do we know? But tangent line is perpendicular to normal line. You can see from the diagram and from our definition. So then what do we know about perpendicular lines? That means the product of their gradients should be equal to -1. So then if we let m2 to be the slope or gradient of the normal line, then what can we say? You already know the gradient of the tangent line, which is m1. And now we are saying the slope of the normal line is m2. And the two lines are perpendicular. It means that the product m1, m2 should be able to give us -1. That is the condition for two lines to be perpendicular. That if you multiply their slopes or their gradients, you need to get -1. So if you know m1, it is possible to get m2. So from here, m2 is simply equal to -1 over m1. So we now know how to find the slope of the normal line and the slope of the tangent line. Now what we remain with is, how do we find the equation of tangent line? You know, the tangent line passes through, let me just sketch here to explain. Uh, let's say that's the tangent line. And we know this line passes through point x naught, y naught. You also need to think of another point, which is xy on the line, a general point. And we know the slope. The slope is equals to m1. For you to find the equation, you need to know the slope of the line, a particular point on that line, and a general point on the line. So therefore, the equation is change in y over change in x is equals to the slope, of which if I substitute, I'm going to get change in y will be y minus y naught. Change in x is x minus x naught. And our slope is equals to m1. So this is the equation of the tangent line. Y naught and x naught, those are constants. X and y, those are variables. M1 is the slope, which is also a constant. Remember, you could write the equation in the form of y is equals to mx plus c when you make y the subject. So this could also be written as, let me make y the subject. You can also write this as y is equals to m1 times x minus x naught plus y naught, which can give you y is equals to m1x plus y naught minus m1 x naught. Or simply y is equals to m1x plus c. So we can talk of y is equals to m1x plus c1. Another form of writing the equation of the tangent line. But whichever form is okay, even if you leave it as y minus y naught over x minus x naught is equals to m1, that will still give you the equation of the tangent line. So let's see how to find equation of normal line. So I'm going to write. Another one is equation of normal line. Again, I'm going to sketch this line. We have this line as a normal line. We know a normal line also passes through point x naught, y naught. Think of any other general point, call it xy, and you will know the slope. The slope of this line is equals to m2. So it is now easy to find the equation. So from here, we again know that change in y over change in x should be equal to the slope. Change in y is the same as, you can just write or, let me write or, y minus y naught over x minus x naught is supposed to be equal to m2, because that's the new slope of the normal line. So this is how to find the equation of the normal line. When you know the slope, you know a point on that line, and you also know a general point on the line. You could also write this in the form of y is equals to mx plus c. So having explained how to find the gradients of those two lines and the equations, let's see some examples where we need to find the equations of tangent and normal line. So we'll have two examples. Example number one, let me write it. Examples. It is find the equations of tangent line and normal line to the following curves at the indicated points on the curve. Part A. We are given the curve x squared plus 2xy. Let me write x squared plus 2xy plus 3y squared is equals to 17. Sorry. And the point here is 1, 2 at point 1, 2. So let's see how to find those two equations. Solution. Now, what you need to take note of is that you must ensure that the given point passes or lies on that line. Take note, first of all, ensure. You need to carry out a check to ensure that the given point lies on the curve. You might be given a point that is outside, that does not lie on the curve, then that means you cannot be able to find the equation of tangent and normal, because a tangent must touch the curve at that point. If the point does not lie on the curve, don't even proceed to find the equation of tangent and normal. Let's see. X value is 1. Put x is 1, y is 2. So what do we get? That means 1 squared plus 2 into 1 times 2 plus 3 into 2 squared. What is it equal to? That is 1 plus 4, that's 5. 5 plus 12, that is 17. So therefore, that means the line or the given point satisfies the equation. This means that point 1, 2 lies on the curve. So now we can proceed to find the equation of tangent and normal line. Now let's find the y dx. Look at our function. This is implicit function. And you know how to differentiate implicit functions. You don't need to make y the subject. We are going to use implicit differentiation. So the step 1, find dy dx. So let's work it out. That means I'm going to use implicit differentiation. So I write using implicit differentiation, we have, let's differentiate this one. Let me bracket it so that you see what you are differentiating. This is what I'm differentiating, this equation. Let's differentiate x squared. That will give us 2x plus 2. Now, here we have x times y. So one of them is u, another one is v. Product rule, you keep x constant, differentiate y, that is dy dx. Plus now keep y constant, differentiate x, that is 1. Then plus 3. When you differentiate y squared, you get 2y times dy dx is equals to derivative of 17 is 0 because 17 is a constant. This you can also write as or 2x plus 2x dy dx plus 2y plus 6y dy dx. That should give us 0. And now I can collect the like terms. Here we have 2x plus 2y. Then the coefficients of dy dx will have 2x plus 6y dy dx. They should be able to give us 0. Or make dy dx the subject. So we'll have dy dx is equals to negative 2x plus 2y, everything over 2x plus 6y. And if you simplify, you see 2 is common in the numerator and denominator. That will give you negative 2x plus y over 2 into x plus 3y. And so the 2 will cancel in the numerator and denominator to give us, therefore, you can say therefore dy over dx is equals to negative of x plus y over x plus 3y. So that is our dy dx. So that's the first step. The next step, you find the slope of tangent and normal lines. So that is the first step. Step 2. Step 2. Find M1 and M2. We said M1 is the slope of the tangent line and M2 is the slope of the normal line. So we said that how do we find M1? M1 is simply dy over dx at the given point, which is 1, 2, x naught, y naught. So when you substitute x is equals to 1 and y is equals to 2 in our expression for dy dx, what do we get? We are going to get negative of 1 plus 2 over x, which is 1, plus 3 times y, that is 3 times 2. And when you simplify that, I can see negative 3 in the numerator. Denominator, we have 1 plus 6, that is 7. So that's negative 3 over 7. Negative 3 over 7. That is our gradient of the tangent line. What about M2? M2 is equals to negative 1 over M1. So that will give us negative 1 over negative 3 over 7. And so that will give us 7 over 3. Now we know the slopes of tangent and normal line. Now the last step, step 3. Find equations. Find equations. Find equations of tangent and normal lines. So let's start with the tangent. Tangent line. Change in y, that is y minus 2. Change in x will be x minus 1 is equals to M1, which we have found to be negative 3 over 7. That is the equation, or this you can write as, or If you make y the subject, you're going to get y is equals to negative 3 over 7 into x minus 1. Then you add 2 plus 2, of which you can also write this as, if I open the bracket on the right hand side, that will give us this one. This will give us, or y is equals to negative 3 over 7 x plus 3 over 7 plus 2. What is 3 over 7 plus 2? That is 17 over 7. So plus 17 over 7. Any form is okay, whether you left your answer as y minus 2 over x minus 1 is equals to negative 3 over 7. It's still okay. You don't even have to write in the form of y is equals to mx plus c. That's still the correct equation of that tangent line. Let's see the normal line. How do you find the equation of a normal line? Normal line, again, change in y will be y minus 2. Change in x is x minus 1 is equals to m2, which is 7 over 3. So that is the equation of the normal line, or you could write this as y is equals to 7 over 3 times x minus 1, then plus 2, which you can simplify to get, when you simplify the right-hand side, you're going to get y is equals to 7 over 3x, then minus 7 over 3 plus 2. That will give us negative 1 over 3. So minus 1 over 3. So this is very simple, as you can see, how to find the equations of tangent line and normal line. What is important here is just knowing how to differentiate the given curve. You see, in this case, our curve was an implicit function. And so that's why we applied the implicit differentiation. It doesn't depend on whichever function that you're given, that will tell you which technique of differentiation you're supposed to apply. I want to give you another one that is very simple. You are asked to find the equations of tangent line and normal line. Let me give you one where we have to apply parametric differentiation. And once I've done the first two examples, it will now be easy for you to do further practice in this area. So I want to look at another one, example 2, or part B. Part B, you are given that x is equals to t squared over 1 plus t. Y is equals to t cubed over 1 minus t. T cubed over 1 minus t. At the point where, t is equals to 2. And the point where t is equals to 2. You see, when we talk of a point has the x and y coordinates. You pair them. So we will need to know when t is equals to 2, what is x and what is y, so that we know the exact point. Solution. When t is equals to 2, comma, x will be equal to 2 squared over 1 plus 2, which is equals to 4 over 3. And y will be equal to 2 cubed over 1 minus 2, that is negative 8. So therefore the point is, the point is, the x coordinate is 4 over 3, the y coordinate is negative 8. That is the point where we need to find the equations of the tangent and normal lines. That is the point of contact between the tangent and the curve. Of course, it lies on that curve. So let's find dy dx as usual. Step 1. Find dy dx. So how we are going to differentiate this function. This is parametric functions. So we are going to use parametric differentiation. Parametric differentiation. Why? Because we have parametric functions. X is a function of t, and y is also a function of t. So let's find those derivatives, dx dt. Dx dt, how do you differentiate a quotient? Use quotient rule. The denominator is v and the numerator is u. So you remember, it is always, take note that to differentiate u over v, it is equals to u prime v minus u v prime everything over v squared, quotient rule. So that's what I'm going to use, because now you say let this be u and this one is v. So u prime, that will give us 2t. V is 1 plus t minus u, which is t squared. V prime is 1. Everything over v squared, which is 1 plus t, and that is supposed to be squared. If I simplify, what will I get? If I simplify, you see I'll be having in the numerator, we'll be having 2t plus 2t squared minus t squared. So that's the same as 2t plus t squared. 2t plus t squared over 1 plus t, and this is supposed to be squared, so that if I simplify that further, 2t is the same as t outside into 2 plus t. Well, let me just leave it as that. Also find dy dt. Dy dt, another quotient rule. Now our u is t cubed and our v is 1 minus t. So this is our v. U prime, that is 3t squared times v, which is 1 minus t, minus u, which is t cubed, times v prime, which is negative 1, everything over v squared, and that would be 1 minus t, the whole of that is squared. Again, you can simplify this. What will it give us? 3t squared minus 3t cubed plus t cubed. So that will give us 3t squared. Look at this, minus 3t cubed plus t cubed. That is minus 2t cubed. Everything over 1 minus t, and this is supposed to be squared. So, how do we now find dy dx? You can now say that therefore, dy dx is the same as dy dt divided by dx dt. Let us divide those two. Remember, when you're dividing, it's like multiplying by the reciprocal of the denominator. So our numerator is 2t plus t squared over 1 plus t, and this is squared. We are dividing by, remember this is numerator. Denominator is 3t squared minus 2t cubed over 1 minus t squared. Are we able to rewrite this? Yes, this is the same as writing of course. You see he will have t times 2 plus t over 1 plus t, and this is squared, times the reciprocal of the denominator, that is 1 minus t squared over, there we have t squared common, t squared outside, into 3 minus 2t. And you can see one of the t will cancel. Can factorize, you can be able to simplify that. This can as well be written as equal to 2 plus t times 1 minus t squared over 1 plus t squared times t into 3 minus 2t. What I've done is that this t has cancelled with one of the t's. So now that is dy dx. That is step 1. We have managed to find dy dx. Step 2. Step 2. We need to find m1 and m2. Find m1 and m2. Look at the point of contact. It is the point where t is equals to 2, or the point 43, negative 8. But look at our dy dx. It is a function of t. So I'm going to substitute the value of t, which is 2, to know our dy dx at that point. So from the definition that m1 is equals to dy dx at the point where t is equals to 2. And so what will it give us when you substitute? Where there is t, you put 2, so we'll have 2 plus 2 times 1 minus 2 squared over 1 plus 2, this is squared, times 2 times 3 minus 2 times 2, that is 4. Let's simplify this. In the numerator, we'll have 4 times, of course it is 4 because it is 4 times negative 1 squared, which is just 4. What about denominator? 1 plus 3 squared, that is 1 plus 2 squared, that is 3 squared, which is 9 times 2. So we'll have 9 times 2 times negative 1. So that is negative 18. That's what we have, negative 18. Of which, if you simplify, you are going to get negative 2 over 9. So that is our M1. And M1 there denotes the slope of the tangent line. So how do you find the slope of the normal line? M2. M2 is equals to negative 1 over M1. And so that is negative 1 over negative 2 over 9. And so that will give you 9 over 2. So now we know M1 and M2. The last one is to find the equations of those two lines. Step 3. Find equations of tangent line and normal line. Remember the equations. Let's start with the tangent. Tangent. You're going to say change in y is the same as y minus, what was the point? It was 0.43. Of course, we can say at 0.43, and that should be 3 in the denominator. 43, comma, negative 8. So that would be y minus negative 8, which is y, let's say minus negative 8, over x minus 4 over 3 is equals to m1, which is negative 2 over 9. This you can also write as y plus 8 over x minus 4 over 3. That should be equal to negative 2 over 9. Or you could express that in the form of y is equals to mx plus c. You can make y the subject, but there's no need unless you're asked that leave your answer in this form. That's when you need to make y the subject. Or if you have time, you can also make y the subject. What about normal? Normal line is change in y is y minus negative 8. Change in x is x minus 4 over 3 is equals to gradient of normal line, that is m2, that is 9 over 2. And this can also be written as y plus 8 over x minus 4 over 3 should give us 9 over 2. So again, we have managed to find the equations of tangent line and normal line to the curve that is defined by the parametric equations. So whichever curve you are given, as long as you are able to find dy over dx, it will be very easy to find the slopes of those two lines and the equations. So that's how you apply the concept of differentiation to find equations of normal line and tangent line And those two lines are perpendicular, the concept of perpendicular lines. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you'll find me right there. Also, comment, like, and share this video. When we meet next time, we will look at other applications of differentiation in real life situations. Bye-bye.